test for testing a hypothesis, and it will give statistical distribution, maybe normally distribution, then such a test are called a parametric test. At the time of the application of some test for testing a hypothesis, the normality cannot be seen, then such type of tests are coming under non-parametric test. So non-parametric tests are otherwise called a distribution-free test. Then what is the advantage of using non-parametric tests? The non-parametric tests are more robust than parametric tests. In other words, they are valid in a broader range of situations. Under fewer conditions, we can apply non-parametric tests because these tests have no distribution to assume. But what is the advantage of using parametric tests? The advantage of using parametric tests instead of a non-parametric equivalent is that the former will have more statistical power. So parametric tests are more statistical power because such tests are backed by statistical distribution, maybe normal distribution. In other words, a parametric test is more able to lead to rejection of a null hypothesis. See, what is the relevance of hypothesis, null hypothesis? Or what is the objective of testing a hypothesis? In research, especially in social science subject, the main aim of testing a hypothesis is to reject a null hypothesis. What is a null hypothesis? The null hypothesis is a statistical assumption having no relation. What's a word to start the null hypothesis? There is no significant relation. There is no significant dependence. There is no significant variation. So, the main aim of testing a hypothesis in social science subject is to reject the null hypothesis and accept the alternative hypothesis where we can have strong relation. We can have strong relation. Hello? Online class. So, the main aim of testing a hypothesis, especially in social science research, is to reject the null hypothesis and to accept the alternative hypothesis. So that is why parametric test has more statistical power than non-parametric test, which means a parametric test is more able to lead to a rejection of null hypothesis. That is the main aim, rejection of null hypothesis and acceptance of alternative hypothesis. And most of the time, the p-value associated to parametric test will be lower than the p-value associated to non-parametric test equivalent that is run on the same data. That is very important. The p-value associated to parametric test will be much lower than the p-value associated to non-parametric equivalent. If we use a parametric test, definitely you have a lowest p-value which indicates whether the hypothesis is accepted or rejected than the p-value given by the non-parametric test. So therefore, use of parametric test has more power, statistical power, than the application of non-parametric test. Again, parametric analysis to assess group means if the mean is better measure and you have sufficiently large sample size, a parametric test usually is the better, more powerful choice. I think some of the participants already completed MPhil, PhD. What we will do in parametric test, in the application of parametric test basically. When you use a parametric test, definitely we will compare the group means. At the time of the application of parametric test, definitely we will have a value. That value is the mean for comparison. Mean value, average, arithmetic mean. But when we use non-parametric test to compare some groups, here the statistic is instead of mean, but median. I mean, if the median is the better measure, consider a non-parametric test regardless of your sample size. So normally this concept, this condition, this assumption may not be understood by many researchers who are doing research or completed research. What we will do in the application of parametric test, simply we compare group means, average, mean value. Mean values have to be compared in parametric test and find out the variation, whether the variation is significant or not. But when we use non-parametric analysis, instead of comparing group means, we compare median. Theoretically, it is okay. But practically, in the non-parametric test also, we compare mean ranks. Mean ranks in non-parametric comparison. Again, what are the assumptions? What are the differences between parametric and non-parametric? In the case of parametric test, we have certain assumptions, conditions. That means the parent population from where the sample have been normally distributed. The data you collected will definitely give normal distribution. This is an assumption for parametric test. But not such assumption is made at the time of the application of non-parametric test. Central tendency value, I have already mentioned at the time of the application of parametric test, what we will compare? We will compare mean value of certain groups. And here, instead of mean value, we compare median value, theoretically. But practically, we compare mean ranks. Correlation. Normally, in parametric test, we use PSN correlation. That means correlation can be applied in a research situation as a parametric test. But in the case of non-parametric stream, we apply Spearman rank correlation. Then in the parametric test, we have a probability distribution that is called a normal distribution. But no such distribution can be seen at the time of non-parametric applications. Population, what is the condition for the population in parametric test? Population must be there. The behavior of the population is predicted at the time of the application of parametric test. The population must be there. But no such population is necessary in non-parametric applications. And parametric tests can be used against interval data. See how many scales? Nominal, ordinal, ordinal ranking, interval, ratio scale, and parametric tests can be applied against interval data only. But non-parametric stream can be applied against nominal data, sometimes ordinal ranking data also. So this is very important. Parametric test can be applied against interval data. And non-parametric stream can be applied against nominal data or even ordinal ranking scale data. Then applicability. Parametric test should have clear variables classified into dependent and independent. But not such classification is seen in the application of non-parametric tests, where we have only attributes. So what's the difference between variables and attributes? Variables may be quantitative variable or qualitative variables. A variable that can be expressed numerically is called a quantitative variable. So in the parametric stream, we have only quantitative variables that are taken into consideration. But in the case of non-parametric stream, we will take attributes, otherwise called qualitative variable, attributes. And examples of parametric test are reset test, t-test, one-way ANOVA, two-way ANOVA. And examples of non-parametric streams are Kuskal-Wari test, Mann-Whitney U test, chi-square test, where we have no statistical distributions to assume. But in the case of parametric stream, we have statistical distribution. Statistical distribution must be there. Normally, the normal distribution can be given by the data you collect. So the first question is over. What is the first question? What is the difference between parametric and non-parametric test? So these are about the parametric and non-parametric differences. Again, the second question, what is hypothesis testing? So normally in the PG program or even MPhil program, when we deliver a talk in the classroom, normally we ask this question, what is hypothesis? In scientific research, there will not be any hypothesis. The output is taken by or taken from an experiment where everything will be true, the natural truth. S2O, 2 molecules of hydrogen, 1 molecule of oxygen will give water. NH4, 1 molecule of nitrogen, 4 molecules of hydrogen will give methane, NH4. So in the laboratory where there is an experiment and the experiment will give an output and the output is a natural truth. There is no way for verifying its natural truth because the truth already spontaneously comes. But in social science research, there is only assumptions, assumed relationships. Assumed relationships are the base for social science research. One variable is connected to another variable. Again, that variable is connected to some other variables. So there is a network of relationship, chain of relationship, and such a relationship has to be proved with the data. That assumed relationship is called a hypothesis. At the time of literature review, the researcher identify n number of variables classified into dependent and independent and try to establish some relation. That assumed relationship is the base of social science research. So the assumed relationship, tentative relationship between independent variable and dependent variable is called a hypothesis. If a researcher frames a hypothesis, definitely there will be the assumed relationship between dependent variable and independent variable. If there is a hypothesis having no such a relation, assumed relationship between dependent variable and independent variable, that may not be a hypothesis, it is only a statement. So what is hypothesis? Simply, hypothesis is the tentative relationship between dependent variable and independent variable. Such a relationship has to be proved with data. So data has to be collected by the researcher only for validating the hypothesis. Validating here means testing the hypothesis and to prove whether it is true or false. So that type of hypothesis testing is seen only in social science research. In scientific research, such type of hypothesis may not be formulated and tested to prove its validity. But in social science, hypothesis is necessary because in social science subject, one factor is connected to some other factor. Again, some factors are again connected to some other factors subsequently. So there is a chain of relationship, network of relationship among certain variables classified into dependent and independent, and such assumed relationship is called hypothesis, and that hypothesis has to be proved or validated with the data. For that purpose, we collect data from different sources. Here, hypothesis testing is an act in statistics whereby an analyst tests an assumption regarding the population parameter. See, we collect data from selected respondents from the population. If we collect information from all the units in the population, it is called census inquiry. But instead of collecting information from all the units in the population, we select certain units from the population and collect information them. Collect information only from them. So that is called sampling. So here there is an assumption. The sample selected from the population should be the true representative of the population. And the parent population from where the sample have been drawn are normally distributed. These two conditions, these two assumptions are very, very important at the time of the selection of sample from the population. So, after selecting the sample from the population and collecting them, the data, then the data has to be analyzed. Then we will get some statistic, sample statistic. So, for example, the total number of customers in a bank branch, SBI branch, university, SBI branch, university, Palayam. Large number of customers are there. The population is very large. And I select 1,000 customers only and collects information from them. So my sample constitute only 1,000 customers. I collect information from only 1,000 customers, analyze such information, such data, and get some values, some statistic. Maybe mean at the time of application of chi-square, I get chi-square value. At the time of application of t-test, I get t value, then z value, or ANOVA f value, whatever it may be. That value is called sample statistic. And I use that sample statistic to measure the unknown value of the population parameter. Here the population is very large. Large number of customers are daily connecting to this bank branch, the branch of SBI University branch. So what we will do in sampling? In sampling or at the time of testing a hypothesis, the sample statistics shall be used for predicting the unknown value of the population parameter. In a simple way, I can speak what we will do in sampling. The sampling result or the study result shall be used for generalizing the behavior of the population. So the methodology employed by the analyst depends on the nature of the data used and reason for the analysis. So these are the steps in the testing a hypothesis. The first step, state the null hypothesis. And I had already explained what is null hypothesis. The null hypothesis means the statement which is clearly mentioned that there is no significant relation, there is no significant dependence, there is no significant variation. So three words are very important at the time of testing a hypothesis or formulation of hypothesis itself. The first one, dependence, second one, variation, and third one, the association or relation. There is no dependence, there is no significant relation, there is no significant association, there is no significant variation, which means that there is no relation. That means there is null hypothesis. So null hypothesis means express the relation in negative terms. There is no relation. That is null hypothesis. The second step said the alternative hypothesis. What is alternative hypothesis? If you have a null hypothesis, there is no relation. Alternative hypothesis shows that there is strong relation. So if there is no relationship between two variables, that is null hypothesis, then the alternative hypothesis should be there is strong relation. So state the null hypothesis first step and state the alternative hypothesis second step. And fix the level of significance. Normally the question asked in every seminars or conferences or its workshop relating to research methodology, sir, what is the level of significance? What do you mean by the term level of significance? So level of significance means the probability of occurring the type 1 error, level of significance. See, normally in social science, we fix the 5% level of significance. If we repeat a particular experiment 100 times, 5 times there may be the possibility of occurring error. Remaining 95 cases, our result will be the true. So for example, from Palayam SBI branch, I selected 1,000 customers and measure their satisfaction, customer satisfaction. So measure the customer satisfaction for the customers of SBI Palayam branch, University branch. I selected 1,000 customers only. My sample size was 1,000. I collect data, analyze it, and I found that customer satisfaction is dependent on the good quality services offered by the branch. My conclusion is like this. My finding is like this. Customer satisfaction of SBI University Palayam branch is fully dependent on the good quality services offered by this bank, this branch. This is my findings. For that purpose, I selected 1,000 customers, collect data, and analyze it. My finding is like this. So after getting these findings, I conduct that experiment once again. Once again, I select 1,000 customers, collect information, analyze it. So in the second time also, my finding is like this. Customer satisfaction is fully dependent on the good quality services offered by the branch, bank branch. So I repeat that experiment 2 times. 2 times I may have the same result. Third time I again conduct that experiment. Again, I select another 1,000 customers and collect data, analyze it, then I may have the same findings. If I repeat 100 times the same experiment, there may be the possibility of 5% errors to occur. That is called the level of significance. That means remaining 95 cases, I will have the same result. Therefore, the validity of the finding is totally validated. The strength of the finding is totally validated. Why? If I repeated that experiment 100 times, 95 cases, the result will be the same. Only 5% there may be the possibility of occurring an error. That error is called a level of significance, 5%. Or otherwise, probability of occurring type 1 error. So we fix the level of significance normally in social science subject at 5%. This is the step 3. Then step 4, collect the data. In order to test the hypothesis or validate the hypothesis, you need data and its analysis. Step 5, calculate test statistic. Based on the nature of the data, nature of the variable, we will decide which is the appropriate statistical test. If we have no distribution, definitely you will go for non-parametric test. If your data conform to normal distribution, definitely you will go for parametric test. If you have two means to compare, two mean values to compare, you will apply independent sample t-test. If we have more than two means to compare or to compare its variation, definitely instead of t-test, you will apply one-way ANOVA. Like that, we will use a test statistic, decide the test, appropriate test. And step 6, after applying a statistical test, whether it is parametric or non-parametric, then you decide whether you accept or reject the null hypothesis. And at the time of application of SPSS software or some other software for testing a hypothesis, or application of some other statistical test, definitely you would consider the p-value. If the p-value is less than 0.05, what is 0.05? Level of significance is 5%. 5% means 0.05. If the p-value is less than 0.05, definitely you will reject the null hypothesis. Otherwise, we will accept the alternative hypothesis. And the last step 7, based on the calculation of test statistic, maybe chi-square test, or even t-test, or even a one-way ANOVA, or whatever it may be, and acceptance or rejection of null hypothesis, we will have certain conclusion to be made. This is the last step. So these are the various steps at the time of testing of hypothesis. So this is the second question. What is hypothesis and what are the procedure for the testing of hypothesis? Again, the third one, the third section, correlation and regression. This is the most important topic in statistical analysis or research methodology or even quantitative techniques. It is very easy to teach in the classroom. I think many of the teacher candidates who are willing to write the PSC examination to get a job in government college, or even MPhil students or PhD students or those who completed the PhD, clearly indicated that correlation and regressions are very simple. Okay, of course, it is very simple. Simple to teach, simple to learn in the classroom. But the most controversial topic is, I should say, the correlation and the regression. The most misused topic, correlation and regression. Anyway, firstly, I will try to compare these two, correlation and regression. Correlation clearly mentioned the relationship between two variables, whether two variables are closely related or not. So correlation is a measure which clearly indicates whether two variables are related or not. Price and demand, whether there is any correlation. As the price increases, automatically the demands will come down. So there may be the correlation. There will be a correlation between price and demand, charging for the commodity. So correlation clearly mentioned the relationship between two variables. But regression clearly mentioned one variable affects the other, whether one variable affects the other. So in the correlation, what we will do? In correlation, we try to establish the relationship between two variables expressed numerically. One statistical value which clearly indicates whether the two variables are related or not. But in the case of regression, we clearly mention what is the rate of change of one variable in terms of another. Then, the correlation, whether the variables are moved together. Correlation clearly mention the movement of variable together. But in regression clearly studied the cause and effect relation. What are the different causes which have certain impact, certain effect on another variable? Cause and effect relationship can be measured through regression. But in correlation, there is two way. Demand clearly relates to price. Price relates to demand. Two-way relationship can be explained by using correlation. But in regression, there is only one way. What is the impact of customer satisfaction on customer trust? What is the impact of organizational commitment on the loyalty of employees? Or what is the impact of customer satisfaction on customer loyalty? So, in regression, there is one-way relation. But at the time of using the regression, one should be very careful. There are certain assumptions. There are certain conditions upon which the regression shall be used. Here, the regression is used against the primary data and secondary data. Against the primary data, of course, it is very easy. So many factors affecting customer satisfaction. So customer satisfaction is a dependent variable. That means the effect. And so many factors affecting customer satisfaction. Maybe good quality products, cheapest price, after sales service, n number of factors affecting customer satisfaction. These factors are called independent variable. These are called causes, cause and effect relationship. Of course, we can apply regression and ascertain the R square value, noted the R square value. If the R square value is much higher, of course, the validity of the regression is very good. But in some of the cases, R-square value is very low. That means there are unobserved variable, more unobserved variable. Such unobserved variables are very, very important in research. Unobserved variable means there is a chance of eliminating some of the powerful variable in the regression model, and such powerful variables are very, very important in research. So at the time of application of regression, definitely the researcher is trying to get more R-square value from inclusion of more and more variable into the model. That is very important. And at the same time, if you add more and more variable into the regression model, definitely your R-square will be much improved. You will get the highest R-square. That is a very good sign. Next one, beta coefficient. Beta coefficient clearly indicates what is the rate of change of one variable in terms of another. Why customer satisfaction is increased? Or what is the effect, causes of, what is the strong causes of a variable which give more customer satisfaction? So beta coefficient clearly tells you that what is the impact of one variable on one dependent variable, independent variable on one dependent variable. So these two are very, very important at the time of the application of regression. R square and beta coefficient. These two are very, very important for interpretation. So this is very simple application of regression against primary data. But application of regression against secondary data, especially time series, then that regression is otherwise called OLS, ordinary least squares. Not ordinary simple regression. Here the regression is otherwise called OLS, ordinary least squares. Because there are so many conditions that are to be satisfied at the time of the application of regression against secondary data, especially in time series or some other models. So what is the linear relationship? A linear relationship is a statistical term used to describe a straight line relationship between two variables. If the relationship between two variables are moving straight, we can say that there is a linear relationship. Linear relationship can be expressed either in a graphical format where the variable and the constant are connected via a straight line, or in a mathematical format where the independent variable is multiplied by the slope coefficient added by a constant which determines the dependent variable. So at the time of the using of regression against secondary data, there will be the linear relationship that can be expressed graphically. That is the first condition. Then properties of OLS estimators. Linear regression models have several applications in real life. In econometrics, what is econometrics? Application of statistics in economics is called econometrics. In other ways, application of regression in economics is called econometrics. This is a wide topic, econometrics. So here in econometrics, ordinary least square method is widely used to estimate the parameters of linear regression model. For the validity of OLS estimates, there are assumptions made while running linear regression models. The first assumption 1, linear regression model is linear in parameters. So there is a linear relationship between dependent variable and independent variable. First condition that must be satisfied. Second one, there is a random sampling observations. If you collect data and random, that must be suitable for analysis. The conditional mean should be 0. The conditional mean should be 0. Another assumptions. There is no multicollinearity, perfect collinearity, which means there will not be the interconnection Intercorrelation among independent variable. If you have interconnection or intercorrelation among independent variable, there is called multicollinearity. That multicollinearity shall be reduced to the minimum so that we can fit the good regression model. And assumption number 5, there is het homoscedasticity and no autocorrelation. So there will not be any heteroscedasticity and there will not be any autocorrelation, serial correlation. That is very, very, very important assumption and condition upon which the regression shall be applied against the secondary data. And assumption number 6, error time should be normally distribution. What is error time? Unnecessary variable. So 75% R square. That means 25% variable that we will not be considered here. And that 25% variable normally error. And that error should be normally distributed. And these assumptions are extremely important because violation of any of these assumptions would make OLS estimates unreliable and incorrect. See, if you apply regression against the secondary data, especially against the same series data, these 6 assumptions or conditions must be satisfied. Then only you can apply the regression in a better way. So specifically, a violation would result in correct signs of OLS estimates, or the variance of OLS estimates would be unreliable, leading to confidence intervals that are too wide or too narrow. So I should say it is better to apply regression against the primary data. You have to observe 2 values only, R square and the beta coefficient. But if you apply regression against the secondary data, definitely you will have more conditions and assumptions that are taken into consideration. Here we have 6 conditions or assumptions upon which the regression shall be applied against the same series or secondary data. The first one, linear regression model is a linear in parameters. There is random sampling of observations. The conditional mean should be 0. There is no multicollinearity. That means perfect collinearity must be there. Multicollinearity must be eliminated or reduced to the minimum. Then there will not be any heteroscedasticity or autocorrelation. That means homoscedasticity is there and serial correlation or autocorrelation cannot be seen. And the last assumption, errors, unobserved variables, and the data shall be normally distributions. So these are the assumptions under which the regression shall be applied against the secondary data. So the third portion is over. Now, I'm trying to give 2 problem questions. The first one chi-square, the second one ANOVA. So there may be the possibility of asking these 2 questions, chi-square and ANOVA, because these 2 are included in the syllabus of the PSC examination. I don't know whether these 2 questions may be asked or not, but there may be the possibility. The first one, chi-square. See, it is impossible to solve this problem through online classes, but I will explain it, chi-square. Joint family, nuclear family, 2 groups. Men and women, the respondents may be categorized according to their gender, men and women. So there is a hypothesis normally. What is the hypothesis we can formulate here? The preference of men and women in the joint family and the nuclear family. The preference of men and women is dependent on the type of family. See, what is the hypothesis here? There is no significant difference between, or there is no significant difference between the gender of the respondent and the type of the family for a preference. Preference on anything. So there is no significant difference between the preference of a particular item for men and women on their type of family. This is the hypothesis. This is a null hypothesis. And by using this null hypothesis, we collect data from total of 661 respondents. Out of them, 131 men, 530 women, 395 coming from nuclear family, 266 coming from joint family. So these are the frequency distribution, not a value, because there is two categorical variable according to family type, two family, joint family, nuclear family, according to gender, men and women, two categories are there. So here the row wise two category and column wise two category. Here the scale is usually is nominal scale. So when we use nominal scale, definitely we will have only frequency distribution. It will not give normal distribution. Therefore, in order to test that hypothesis, we will go for non-parametric test. Here the two-way tables are there. Two column, two rows. Therefore, it is better to apply chi-square test. And use 5% level of significance. Definitely, by using 5% level of significance, we will identify the table value. Then calculate the chi-square value, compare the table value, then find out whether the chi-square is significant or not. That means whether the null hypothesis shall be rejected or not. So this is the way in which the chi-square can be applied. Then another question, ANOVA. Here, four populations are here. X1 population 1, X2 population 2, X3 population 3, and X4 population 4. Then from the first population, we have 50 samples. Second population, we have 55 samples. Third population, we have 65. Fourth population, we have 70. So here, these are the numbers, not a frequency distribution. These are the numbers. 1, 2, 3, 4 groups. First group, second group, third group, fourth group. So total 50. We can calculate mean. We can calculate median. Any other descriptive statistics we can calculate. So here we have a mean. Here we have a mean. Third group, again we have a gain. Then in the fourth population, again we have a mean. So we have to compare four mean values at a time. We have to compare four mean values at a time. Here the total 50, total 55, total 65, total 70. Again, we can calculate mean for the first group, calculate mean for the second group, calculate mean for the third group, calculate mean for the fourth group, and compare the mean values and find out whether there is variation is significant or not. So four mean values have to be compared and find out whether the variation is significant or not at a 5% level of significance. If we have more than two group means to compare, if we have more than two mean values to compare, definitely we can apply one-way ANOVA. Otherwise, we can apply t-test, provided the sample size should be less than 20. If the sample size is greater than 20, instead of t-test, we can apply z-test also. Anyway, here we have to compare four group means at a time for finding out whether the variation is significant or not. Therefore, the appropriate statistical method is called one-way ANOVA. So these two are the very important section from where you can expect some problem, chi-square and one-way ANOVA. Two-way ANOVA is okay, but it is very difficult to solve two-way ANOVA in the classroom. Therefore, the PSC test, the two-way ANOVA may not be asked. I think it may not be asked. So these two are the very, very important section from where you can expect simple problems, chi-square and one-way ANOVA. So I stop here. If you have any doubt, please ask. I will explain. Please. Bhagavati? Bhagavati?
Yes, sir. Yes, sir.
Yes, the participants are directed to ask question. Then I will explain.
Yes, sir. Yeah. Dear participants, please do post your questions in the chat box. And those who are viewing this and as a live program, please do post your in the comment session. Please post your doubts in the comment session so that I'll keep asking it when I receive the questions.
However, check the chat box and you just specify the questions. Ask the questions to me. First, you check the chat box and then you.
Yes, sir.
What is this homoscedasticity and heteroscedasticity? Yes, yes, I know, I know. I noticed that question. That is
Yes.
very important. Homoscedasticity and heteroscedasticity. See, heteroscedasticity, firstly, I will explain. The value of a share in the stock market, the value of a share in the stock market. See, share value today, 1000. Tomorrow, 1200. Day after tomorrow, 1100. After 5 days, the value of share in the stock market, 3500. Sixth day, it will be reduced to 1000. Increased to 1100 the next day. Again 1200 the next day. But there is only one value which is always above 2000. So that is called heteroscedasticity. That means high variation observed in your data. High variation. Only few cases there may be high variation. Fewer remaining cases, the variation is not significant. Only one or two figures that are very high in your observation, that is called heteroscedasticity. And not such element is seen in your observation, that is called homoscedasticity. Another question? I have noticed one another question, econometrics. Econometrics. See, econometrics is a specific branch of statistics. Separate statistical methods are there for application in the economics field, especially time series. Against the time series data, so many assumptions are to be made for the application of statistical technique. So this separated branch is called econometrics. Otherwise called application of statistics in economics is called econometrics. Here we can apply regression against the primary data, apply regression against the secondary data. If you apply regression against the secondary data, so many conditions are to be satisfied. That is why ordinary least square is otherwise called the application of regression in economics, econometric regression, because 6 conditions are to be satisfied. I already explained all the 6 conditions. These are the 6 conditions. These are the 6 conditions. What are they? The linear relation must be there. Random sampling observations. Conditional mean should be 0. Multicollinearity will not be there. Then homoscedasticity and must be there. Heteroscedasticity cannot be seen. And no autocorrelation. Error time should be normally distribution. Oh, if all the 6 conditions are to be satisfied, you can apply regression in econometrics. Economic regression you can apply, especially against the secondary data. So that is why OLS, ordinary least square, is basically the regression models applied against secondary data. Then another question?
Sir, how do we know it is a two-way ANOVA?
Simple, very simple. This is one way ANOVA. How many groups? First group, second group, third group, fourth group, column wise. If you are row wise, if you consider the observations row wise, Together with the column wise, this is called a two-way ANOVA. Then level of significance. Good
Sir,
question.
how do we
Yeah.
calculate optimum sample size?
Optimal sample size can be calculated by different formulas. Normally, the optimal sample size can be calculated based on the information we taken from pilot study. This is a separate module. The sample size determination is not seen in the syllabus, I think. Sample size determination. No. Cross-sectional, time series research design, type of data, error hypothesis, substitute, innovation. That is not included in the syllabus. Sample size determination. Yes. Another question?
Sir, level of significance.
Very good question. Very good question. If you ask that question to a PhD holder or an MPhil scholar, they didn't tell the exact answer. Level of significance. So normally in social science we take a 5% level of significance. That means probability of occurring type 1 error. If you repeat that particular experiment 100 times, there may be the possibility of 5% error. You fix it, which means all the 95 cases, your answer will be the same. Only 5% error will come. That is called level of significance. In commerce, in management, in all other social science subjects, we fix the level of significance occurrence of that particular error 5%. That means 95% your answer will be true. You are confident that 95% your answer is true. Only 5% there may be the possibility of some error. And you fix it deliberately or statistically. That is called 5% level of significance. Again. Another question?
Sir, the next question is what is. Sir, shall I?
Yes.
Sir, the next question is what is autocorrelation in regression analysis?
Very simple. Very interesting question. Autocorrelation. See, today November 14th, I think. Now it is here today 14th. So November 1st, value of a share in question exchange 500. November 2nd, 520, which depends on the value of the first day. Number 3, value of the share 600, which is fully dependent on the value of share on number 1 and number 2, which means in the time series data, especially financial data, one figure is connected to another, second figure is again connected to the first figure. So first observation is connected to some other figure, second observation is based on first observation, third observation is again based on second observation. This is called serial correlation or autocorrelation. And that is the phenomena you can see in the time series. Time series only, autocorrelation. Against primary data, there will not be any autocorrelation. But if you rely more on secondary data, especially time series, autocorrelation is a phenomena. That's a danger also. We can reduce it by using some other models. That is why it is called econometrics. Yes, next question.
Sir, one of the conditions is that the conditional mean should always be 0.
The
There
condition,
needs an explanation.
yes, the condition is, 1 second. Optional assumption, sorry. Assumption D, the conditional mean should be 0. Because The mean value observed for time series regression must be greater than 0. So, there is a condition that the mean value should be 0. So, in actual practice, the mean value must be greater than 0. Anyway, there will be a mean. Value of shares in the stock exchange for the last 30 days. Definitely, you will have a mean value. Mean value must be greater than 0. So, the minimum should be 0, but it must be greater than 0. Next question.
Sir, what is statistical inference?
Statistical inference. If you calculate chi square or if you calculate f value, then use that value to test the hypothesis and whether it is accepted or rejected. If you accept, there may be some inference. There is no significant relationship between customer satisfaction and good quality products. There is no significant relationship between customer satisfaction and good quality products. You reject the null hypothesis. What is your inference? After rejecting the hypothesis, there is strong relationship between good quality products and the customer satisfaction. Examples of non-parametric test: chi-square test,
Sir, then
Kuskal-Valley test, then Mann-Whitney test, run test, Wilson test, etc. etc. Another question?
sir, is the
Hmm.
level of significance and confidence level one and the same?
No, not always. 5% level of significance means 95% confidence level. 1% level of significance means 99% confidence level. Okay?
So the next question, what is unabsorbed variables?
Unobserved
Example.
variables are those variables that we cannot take into consideration. In the regression, customer satisfaction is affected by n number of variables. N number of variables affects customer satisfaction. Out of them, you select only 10. Remaining variables are called unobserved variables that we cannot take into consideration. Again,
So the next question is, what are the reliability and validity tests which are specified in the syllabus?
so basically the reliability and the validity, these two tests can be applied to construct a questionnaire for data collection or construct an instrument for data collection. So validity can be checked by using Cronbach alpha validity. Sorry, reliability can be checked by using Cronbach alpha. And validity, the most probable method is the use of factor analysis, halfway factor analysis against the data collected through pilot study. Against the data collected through pilot study, we can apply factor analysis and find out the validity of the instrument. Then,
Sir, the next question is, how much marks can be expected for problem session?
I don't know because in syllabus day before yesterday I got the syllabus. Anyway, you can expect these two questions, chi-square and NOVA. Much complicated problems will not be asked in the examination, I think. Is that enough?
Sir,
Yeah,
the next question is, is
I got that question. Is unobserved variables, read out again. Unobserved variables are intervening variables. No, no, no.
sir, is that is the same as intervening
No, no, no,
variables?
no. Unobserved variables and intervening variables both are different. When?
Sir, one more explanation they want regarding non-parametric test.
What type of explanation? If we have data that normally distributed, definitely we will go for non-parametric test. And put in another way, if we have quantitative variables, put in another way, because if we have certain variables that can be measured quantitatively or numerically, definitely we can apply parametric test. If we have certain attributes measured through certain instruments, then it should not be any distribution to prove, then we will go for non-parametric test. Then if we use interval scale, definitely you can apply parametric test only. If we use nominal scale, ordinal ranking scale, definitely we can apply non-parametric test only. So this is a wide topic. Okay?
Sir, yeah, there are some recommendation of the textbooks
The basic
for
uh,
reference.
the basic textbook is the Fundamentals of Statistics by D.N.L. Hans. The oldest book, if you get it from the market, it is good. Yes. Biju, you are on the line. Biju? Biju sir. Bhagavati?
Sir, a question regarding the methodology of econometrics.
Methodology of econometry is you just observe this slide. This is very, very important. The methodology of econometrics will not be explained in one question, 5 minutes. Definitely we can have another section for econometrics. Bhagavati, again?
So
Yes.
one more question.
Use of,
What are use
use
of
of
different scales like ordinary, interval, etc.?
suppose at the time of construction of a questionnaire or interview schedule, normally the first question, gender, male and female, location, urban, semi-urban, rural. These are the nominal scale used, categorical variable. Your age, open-ended question. Some respondent filled at 65, 35, 40. This is ordinary variable. That means a variable that can be expressed numerically. If you measure a level of satisfaction on 5-point scale or even 7-point scale, this is called interval data. So normally we use nominal scale, ordinal ranking scale, and interval scale for construction of a questionnaire or interview schedule in social science subject. Any other question?
Sir, factor analysis.
Uh, so this is a data reduction technique. If we have n number of variables that are being correlated, based on such correlation, we reduce such variables into some factors. And that is the statistical techniques used for data reduction, factor analysis. But that cannot be explained within 5 minutes, 1 hour. which will take almost 5 hours to complete. Any other question?
No, sir. I've checked in both YouTube chat session and here. The questions are over.
So thank you very much for your patient listening. If I have a chance to deliver the factor analysis or econometrics in summary section, then I'll be ready. Thank you very much.
Thank you so much, sir. As you've said, there are lots of chats in the chat box asking you for one more session. So that shows how fruitful the session was. And on behalf of the Alumni Association and the Department of Commerce, and on behalf of all the PSC aspirants, I extend my thanks to you, sir. Thank you for taking such a wonderful session.
Thank you once again.
Thank you, sir. And that's the end of today's session. And tomorrow we'll be having one session on income tax and GST, which will be taken by Dr. Gabriel Simon Tuttle. Thank you once again for all of you for your kind listening. We'll meet again tomorrow. Thank you.